Now, we will present about the first and second law of thermodynamics. Before start, let me ask you a question first. What is the first law of thermodynamics? The first law of thermodynamics is the law states that the heat is a form of energy and thermodynamic processes are therefore subject to the principle of conservation. This also means that heat energy cannot be created or destroyed. However, it can transfer from one location to another and converted from one to other form of energy. In another word, the first law of thermodynamics is the change in internal energy of a system equals the difference of net heat transfer into the system and the net work done by the system. This is psi conventions of internal energy, heat, and work.
When internal energy is negative, it means decrease in temperature, and positive means increase in temperature. For heat, when it is negative, it means heat is released from the system, while positive means heat is absorbed by the system. Work done by the system is in negative sign, and work done on the system is in positive sign. Now, we will proceed with experiment. In this experiment, the balloon expands when the boiled water is added into the bucket. Heat is transferred from the surrounding, which is boiled water, to the system, which is the air inside the bottle and the balloon.
The heat Q is positive because heat is absorbed by the system, and the work W is negative because work is done by the system. The heat input is stored inside the system as internal energy U before it transforms to work. After explaining the first law, don't forget we have another law, that is the second law of thermodynamics. So do you know what is the second law of thermodynamics? The second law of thermodynamics is the law states that heat transfer occurs spontaneously only from higher to lower temperature bodies. Besides, this law also states that there is a natural tendency of any isolated system to degenerate into a more disordered state.
Any spontaneous process in any isolated system always results in an increase in the entropy of system. This is the equation. Now we will proceed with the experiment.
Experiment 2. We just need some ice and then put it inside the heating pan. Wait until all the ice melts.
The heat from the pan moves into the cold ice cube. The molecules of water in ice cube are warmed up, start to move around, and the ice melts. We will never expect the ice cube to get back to the original number. Same with what we state, heat energy always moves from higher temperature to lower and never in opposite direction.
Now I will explain the difference between the first law and second law of thermodynamics. First law states that energy can neither be created nor be destroyed, while second law states that the entropy of an isolated system never decreases, instead always increases. For the first law, delta U equals Q minus W is used for calculation. The heat change in internal energy is equal to the difference of the heat flow and the work done by the system. For second law, this equation is used. The total change in entropy is the sum of change in entropy of system and surrounding, which will increase for any real process. Example application of thermodynamics in fruit process is drying process for fruit and vegetables like. This law is used to estimate the ratio of energy utilized, while the magnitude of energy lost during the process is calculated using second law. That is all for now. Thank you for your listening. Hope you all can have a better understanding in these two laws after this lesson.